Hello all. Today we're continuing with lesson 4.7, the law of sines and law of cosines, and we're still looking at solving oblique triangles using the law of sines or the law of cosines. But we're looking at something new, namely the ambiguous case of SSA. So if we're given a triangle with a given angle and two sides, and one of the sides is opposite to the given angle, in this case side A and angle A, and side B. We have two cases. When the angle is acute, means less than 90, then we look at whether the first side A is less than B. If A is less than B, then we compare A to the height. If A is less than the height, then there is no solution. If A is less than B and A equals the height, then we have one solution. And if A is less than B and A is greater than the height, we have two solutions. Now, if A is greater than or equal to B, we have one solution. The other part of this table is when A is either right angle or obtuse, means more than 90. In this case, we only have to check whether A is less than or equal B or A greater than B. So if A is less than or equal B, we don't have a solution because this is not a triangle. And if A is greater than B, we have one solution. Now to find the height, if we look at this, sine of angle A is usually the height, which is the opposite, divided by the hypotenuse, which is B. So sine A equals height over B, which means that the height equals B times sine A. So in case we want to find the height for these three cases, we have to use H equals B sine A. Let's look at this example from the textbook. Find all solutions for the given triangle, if possible. If no solutions exist, write no solution. So we have angle A, which is 108, side A equals 9, side B equals 7. Obviously, A is obtuse, means greater than 90, and A is greater than B, because A is 9 and B is 7. So according to this table, A is obtuse and A is greater than B, which means we have only one solution. Now let's draw a sketch of this triangle. Let's say this is angle A, which is 108. This is side A, which is 9. This is angle B, and this is side B, which is 7. So we want to find or solve the triangle by finding angle C, angle B, and side C. First of all, we can use the sine or law of sines. Sine A over A equals sine B over B, which means sine B equals B sine A divided by A. Sine B equals 7 sine 108 over 9, and B equals sine minus 1 of 7 sine 108 over 9. That means B equals 48 degrees. Now we can find C. C equals 180 minus 108 plus 48. That will give us 24. Now to find sine C or side C, we use the sine law. Sine A over A equals sine C over C. C equals A sine C over sine A. C equals 9 sine 24 over sine 108, which will give us 3.9. And that's it. Please pause the video and look at the solution, try to understand it. Let's look at another example, number 11 from the textbook. We have angle A equals 117, side A equals 14, side B equals 15. So obviously angle A is obtuse and A is less than B because A is 14 and B is 15. Now let's look at the table here. We have an obtuse angle and we have A less than or equal B. In that case, we don't have a solution. So going back here, this problem has no solution. We cannot find a triangle with these specifications. And that's it. So please look at the solution, pause the video, and make sure you understand why we came up with this. Alright, let's look at another example, number 12. We have A equals 18, B equals 12, and angle A 27. Obviously, angle A is acute and A is greater than B. So let's look at this. So for acute angles and when A is greater than or equal B, we have one solution. Alright. Now let's say this is the triangle, 27 degrees. This is A, this is B, and this is C. Right here we have 27, and here is 18, 12. Let's start by finding angle B. We know that sine A over A equals sine B over B, or sine B equals B sine A over A. So sine B equals B, which is 12 sine 27 over A, which is 18. Angle B equals sine minus 1, 12 sine 27 over 18. That will give us close to 18 degrees. Angle C equals 180 minus the sum of A and B, 27 plus 18, that will be 135. Now to find side C, sine A over A equals sine C over C. C equals A sine C over C equals A sine C over sine A. A is 18 sine 135 over sine A, which is sine 27. C will be close to 28 when rounded. Alright, so that's it for this example. Please pause the video and try to make sense of what we did here. Let's look at this example. We have side A equals 5, side B equals 6, and angle A is 63, which is acute, and A is less than B because A is 5 and B is 6. So in that case, let's look at what the table says. Angle A is acute and A is less than B. Now we have to check if A is less than the height. So let's do that. To find the height, we know that sine A equals h over B. H equals B sine A equals, B is 6 sine 63 equals close to 5.4. Now since A is less than h, we have A5 and h is 5.4. A is less than h, so according to the table right here, if A is less than B and A is less than h, given that A is acute, less than 90, that means we have no solution. So right here, no solution. Alright, I hope that does it for you. We still have one more exercise, but I'm going to do that in another video because I'm running out of time. Alright, please pause the video and make sure you understand what's going on here.